Tipo has engineered the most comprehensive line of plate processing systems available in the world market today. The plate processors from Tipo can generally be classified in one of two different design styles. The first are gantry-style systems, where the plate remains stationary during the drilling and cutting processes. The other classification of plate processing systems is generally referred to as a pull-through design, where the plate is positioned in the length axis. In synchronization, the punching, drilling, and thermal cutting devices are positioned in the width axis. The most recent addition to this lineup of plate processing systems is the Tipo G. This combines many of the advantages of both design types into a new and uniquely innovative solution for plate fabrication. The Tipo G plate processor incorporates massive material clamps with a rack and pinion material positioning system for moving the stock plate. After the laser senses the leading end of the plate, this system achieves the highest level of accuracy attainable. These positioning clamps can be automatically relocated along the plate to increase material utilization and capacity. This positive material positioning system moves the plate in synchronization with the other axis as required for such processes as bevel cutting. The proprietary Tipo bevel head design permits the torch to float in the holder, so the torch cables remain stationary even when bevel cutting. This eliminates cable fatigue and the need to unwind the cables after each cutting routine as found in outdated designs. Tipo utilizes a double bridge arrangement as part of the Tipo G. This enables the spindle to position in the length axis independent of any positioning of the plate. This maximizes both accuracy and efficiency while greatly minimizing the required movements of the plate. As an option, two independent spindles can be furnished to operate simultaneously, even if the operations are not identical or do not share the same length coordinates. All drill spindles feature a direct drive, so 100% of the motor's power is delivered to the tool, as there is no power loss by having to transmit the power through a gearbox. Each spindle can be provided with a 24-position automatic tool changer to accommodate a wide range of applications. Traveling just below the material pass line, in synchronization with each drill spindle movement, is a rigid underside material support. This design permits that the maximum spindle force and drill feed rates can be utilized without material deflection and vibration. Each spindle is fully independent with its own sub-axis, so when selecting the two-spindle option, both spindles can be fully engaged, performing different operations at varied locations. This configuration delivers up to a 40% productivity increase in the same footprint when compared to a single spindle system. The ability to move the spindles independently when the plate is firmly clamped expands the versatility and capabilities of the Tipo G. Only the spindle is moving in multiple axes to generate such operations as the milling of slots, countersinking, which is based on the top surface of the material by using a non-contact laser probing technology, milling of large diameter holes that exceed the drilling capacity, final milling of thermally generated holes, tapping, thread milling, counterboring, drilling and scribing, or any combination of these typical processes. Tipo's proprietary nesting software maximizes material utilization and the efficiency of operations, as it is designed specifically for Tipo's family of plate processing systems. Functions can be simulated or viewed by the operator on the CNC for automated routines such as counterboring. This innovative software includes the Tipo patented process for the automatic extraction of scribing program data for the intersecting elements in the 3D model. The scribing data on the plate includes locations and part number information to eliminate manual layout for a subsequent fit-up. Part numbers can also be efficiently generated with an optional programmable marking system. Prior to any thermal cutting operations, the chips generated during drilling, for example, are efficiently removed from the plate and placed into a removable chip bin or conveyor. After completion of the desired spindle operations, the stock plate proceeds toward the thermal cutting zone of the Tipo G. Thermal cutting can be achieved with a combination of multiple hypertherm plasmas and 1 or 2 oxy-fuel torches to accommodate thicker plates. As the finished parts are completed, they are unloaded without manual intervention in a continuous automated fashion with a small parts conveyor. FECHEP offers 10 uniquely innovative plate processing systems with differing capabilities and stock plate sizes. This enables FECHEP to match your plate fabrication requirements and configuration to the optimum solution. This is just one more reason to look to FECHEP to address your fabrication needs, regardless of your plate processing challenges. FECHEP continues to always deliver the most innovative and productive solutions to the market.